Okay, so the recording has started. Now in this lecture, what we will discuss is we're going to discuss the Verilog functions and tasks. And basically, here is the Verilog uh, structure of a module. At the end here, you can see that we can have tasks and functions that can be used in coding your module. And these are a little bit more of advanced structure. I wouldn't advise anyone who's learning Verilog today to use them unless you really master the basics of data type, the always and initial and the assign statements, um, and the if statements, the case statements, and they are very useful if you are doing large assignments or projects because functions and tasks they kind of subroutines. You can use them. You can code whatever you want to code as a subroutine and call it how many times you want. But they are different in Verilog. Tasks are different from functions. And let's see what are their differences. I'm going to go for an example here to illustrate what do we mean by their differences. Now, suppose, for example, here I need to get a byte from data. Suppose my data is 64-bit here, for instance, and this 64 bits has 8 bytes, and I need the fourth byte. Let's say I need this fourth byte. So what do? I write a function, right, which called get byte here. And this is the function which is get byte. First of all, the very thing you notice that get byte as a function returns the value, and the value comes with the name of the function, which is get byte. In other words, this is will have a value of the fourth byte from the data, and we're going to assign it to this variable right here. Now, if I look at the how I define get byte function, this is the function here. I define it as 7 bits. It's exactly how I define a variable, right? So this is the name of the function. Notice the keyword function and notice the in function keyword. You must have those when you define a function. All right, you must have those. Then, then here we say I have an input, which is this is the word, right, of a 64-bit, and I have the byte number that I want to pick. Which byte number you want? So you can see when I pass to the get, I'm passing the data here, the 64-bit data and the byte number. Now, here is then what I do in this part here, I'm gonna take out the fourth byte and create this temporary variable, which is temp here, to fill the bits of the fourth byte in this temporary value. So I use a for loop here. Okay. And now once I'm done, okay, picking up all these bits. So basically I put those bits in a temporary variable. Then I copy this variable here to get byte. And notice that get byte is what? Is the name of the function. So I return the output of the function to the name of the function. And then the name of the function will return the output here to the variable this byte. This is how you code a function. Okay, so again, pay attention to the syntax. Notice for a function here, you don't have an output. There is no an output. Reason, there is one single output for the function, and that is the name of the function. It is the output of the function. Okay, that's one of some of the similarities between function and task. Also notice that there is no delay here. So in the task, we can have a delay, but in the function, there is no delay. So the function is more of a combinational circuit, if you will. Okay. So if you look here, basically what we have implemented here is a massive byte selector, or mostly like a huge multiplexer here. Okay, which is a combinational circuit. Now let's take a look at the task. The task, on the other hand, it has inputs and it has outputs, and we return the output. You can have one or two or 10 outputs. You can, and you return to the output. You don't return the output to the name of the task. So in this case, for example, I'm having a read memory, right? For a PC, I'm providing the PC, and I want the data from memory to go to my IR register. So I received the PC here and the address, which is the internal variable, and I received the instruction register in the data here. These are the local names inside the task. So then what do? I set a read request to a one. This is on the bus. Then I wait for this variable, okay, which means this address has to change, right? And then once that happened, I set the address on the bus with the address here. So which is coming from the PC. Then data equals the data bus. I set my data to the data bus. All right. And then I set the address bus. So this is to relinquish the bus. So say I'm not driving this bus again. And then I set the data request to 0. Notice the following is that this is a protocol of accessing the bus. You set read request at the beginning of the read, and you set it to 0 when you are done. You drive the bus with the address, and then when you are done, you relinquish the bus. خلاص بتفلت bus, you don't have. وبالنص you get the data here. Okay, so this data is your output and comes in here, and when you return, this data comes and becomes the value of the IR register, which is the instruction register, that you want to fill the instruction with. Okay, so this is the memread. Notice the syntax: task, the name of the task, right? And then end task. These are syntax issues you have to pay the attention for. Okay, so again, the task and function, these are routines and subroutines that are used, right, in my code for to code things that I repetitively access or I repetitively execute. Okay, these are examples of how to use, again, functions. You can look at them. So we are implementing a function here, my gate. All right, this is my gate, which is based on the this value here, the op. This gate can be an AND gate or an OR gate based on the value of the op. So I created a gate that can be an AND or an OR gate. Okay. Um, Now, the let's see. Okay, so this is the function and the output. Notice the name of the function is my gate. Okay, and my gate here, okay, gets the value of the output of the function. Okay, as we said, the function, the output goes to the gate name, to the function name. Okay, so in this case, for example, I'm saying my gate pass A, B, and 0, and this is like now I'm having an AND gate for A and B, and if I have a 1 here, this is like I'm having an OR gate A or B. Okay, using this assign statement. Okay, so this is an example here. Now, here in the following code, they go into local register and global local variables and automatic variables. I'm going to skip all of that because really this is going too much into the details. I don't recommend you as a beginner in Verilog you go through this. You can read through this yourself, but I don't recommend it that you play with the local variables unless you're really into advanced level of Verilog. Okay, so here we have an example of a task. Okay, let's see. This is a task named what? Run task, and here is an always block. It calls the run task, right? And then after 30, time ticks, we do the run task again. Okay, and then in the run task, we have a delay, and the delay is set to 5 here by this parameter. Okay. Okay, so and this is basically what is described over here. Let's see. So okay, so basically here in this always block, I will wait for event on A and B. One of the A and B C changes, which is right here. Okay. Once something change here, okay, we run the task, which is right here. All right, and then we wait for 30, which is right here, and we run the task again, which is right here. And then we go back and repeat the always block. Okay, so this concludes for me what I want to say about functions and tasks in Verilog. Okay, and I can now um, okay, um, stop the recording. Okay.